Okay, so we know that when we have a complete transfer of energy, that the final speed is going to be just the square root of 2gh. So that's what we have there. And that's a good thing to know too. Like if you have a complete transfer of energy, that you went from all potential to all kinetic, right? So all potential to all kinetic. The final speed is the square root of 2gh. Very useful. In this case, it was 10 square root of 2 meters per second. I'm going to do the same thing now with kinematics. Okay, so I'm going to take this, I'm going to highlight it. Let me highlight this. Take the whole thing across. I'm going to clone it. Move it down. We're going to redo the same problem now with kinematics, just to show you the comparison here. So I'm going to take this eraser and I'm going to wipe this out, except for everything that says assume g is 10 meters per second squared. Same exact concept. Ball is going to be released from rest, fall to the ground. What's the final speed? Well, we have to make one distinction here. We can't work with height. Okay? Well, you could if you had the special modified equations of kinematics, but I'm going to work with displacement all the time. So what I'm going to do is I'm going to change that right there. So we're going to make this going to be delta y, the displacement. It's going down, right? So in this case, I'm going to have it say negative 10 meters because it's going down, right? It's one of the differences. So I'm going down negative 10. Everything else is going to work pretty similar. Okay. So again, going back to the kinematics here, I'm just going to write out my variables. What I have, all the possibilities. So I have acceleration on the y. I have v initial on the y. I have v final on the y. I have delta y, and I have time. These are all my variables, and I need to have 3 of these variables to solve a kinematics equation. So I'm going to move these over a little bit. Just give us some more space here. Okay, so we need 3 variables. So the first one is the acceleration of y is going to be negative 10. Now notice the difference here. When I'm dealing with this component here, these are breaking it up into the x and the y components, or the scalars. This is where the signs matter. Okay, so notice in energy we just used 10 positive. In energy we just used height as positive. Now with kinematics it matters because the acceleration is negative 10. It's going down, right? Because my x and my y are like that. I'm just defining that as my positive direction. Okay, just to clarify that. V initial is 0, starting from rest, right? And my delta y is negative 10. So now if I go through here, I have 1, 2, 3 variables I can start to solve. So what equation can we use with kinematics that has 3 variables that does not have time? It's going to be this one here, which is v squared equals v initial squared plus 2a delta y, like that. So I have everything except for the v. That's what I'm looking for, right? That's what I'm looking for. And we know v initial is 0. Okay. We know acceleration is negative 10. We know displacement is negative 10. So let me solve symbolically for this. V is going to be the square root of 2a delta y. Now I want you to notice the difference here. These two are almost the same exact thing, right? V is the square root of 2gh. V is the square root of 2a delta y. This is g. This is h. Same concept, right? But in this case, you're going to have a negative and a negative. They're going to cancel out. So they're similar. They're a little bit different. Okay. So let's go ahead and solve this out. So v is going to be the square root of 2. In this case, a is negative 10. So negative 10. And delta y is negative 10. So we're going to get the same exact thing. So v is going to be 10 square root of 2 meters per second. So you get the same answer, almost the same formula. They basically are. It's just we have the signs here that we have to account for. Here we don't. Okay, so we get a very similar result here. In the case of this, it's definitely easier to use energy, right? Much easier, right? But if I wanted to find time, if I wanted to find an angle, that's where the kinematics come in handy. So in this simple one-dimensional case, energy was easier, but when you use kinematics, you get the same thing.